Okay, so for knowing the electronic configuration of elements, really one of the simplest way of going about it is to look at the periodic table of elements. And the periodic table of elements arrange the atoms by group here, by group, and by period, going down the period. So you start with hydrogen with only one proton, and so one electron, and this element will be in group 1 of period 1, and then we can go like that all the way, say for example, to sulfur with 16 electrons, and sulfur will be in group, well, period 3, and that's the issue, how many electrons? 16 electrons in total. So that's for us to try to figure out how to fill those electrons all the way down to sulfur, etc. So if we start again, therefore, for the way the atoms are arranged, we can see that first in the group, they're arranged in the first two as S elements, and then they're arranged there with p orbitals, and then for the transition metals, 10 of those, we have the d orbitals, and then for the lanthanides and actinides, there's 14 of them, and there's the f orbitals. Those letters S, P, D, and F stand for the way the elements showed up under atomic spectroscopy. So they had lines, spectroscopic lines, that were called to be sharp for S, principal for P, diffuse for D, and fundamental for F. But that's kind of a historical way of naming the orbitals, and it's being kept. So there's only one s orbital, so we can put 2 electrons in that orbital. There are 3 p orbitals, so we can put 6 electrons. There's 5 d orbitals, so we can put 10 electrons, sorry, in the d orbitals. And there are 7 f orbitals, so we can put up to 14 electrons. The way the electrons are going to be filled for heavy metals, such for example as mercury here, starts to be a little bit complicated, and we're not really interested in those heavy metallic elements. So if we simplify and look, for example, for carbon, so let's see, for carbon. So if I look here at carbon, I have 6 electrons for carbon. Carbon is in period 2, so I can put first 2 electrons in the orbital 1s. I can then put 2 orbitals in the orbital 2s, so that's 4 electrons filled up, and I need another 2 electrons that I can put only in the orbital 2p, and so I can put 2 more electrons in there. So the electronic configuration of carbon for the 6 electrons would be 1s2, 2s2, 2p2. I hope that helps, and if you need more details, sure, give me a shout on the discussion board. Okay, bye-bye.